to another old steam power machine shop. Glad to be putting up another video. Been pretty busy the last month. Did 4 steam and gas engine shows in 4 weeks. The Canandaigua show in New York, and the Kinsler show in Lancaster County, Pennsylvania. Williams Grove Steam Engine Association near Carlisle, and a local show here, the Southern Tier Gas and Steam Engine Association. And haven't had a whole lot of time to get anything done in the shop, so had a few customers' jobs to get out, and did some work on the planer, which I'll show you in a minute. Thanks a lot for all your subscriptions and comments, and we'll get right to the video. This is the Countershaft. It was with the planer. And the Countershaft is a short shaft. It's mounted above the planer, and the power is belted to the Countershaft on one end with a tight and loose pulley, and on the other end of the Countershaft you have the large reverse travel pulley and the smaller cutting travel pulley, and a bearing on each end. And as you can see, it's pretty hacked up. Pulleys have been run loose here. The set screws have gouged it up, and it's been ground on and drilled into so that the set screws would bite into the shaft, keep them from slipping. And it's not worn too bad, but I'm going to make another one, and I'm going to make it, see, this one is about 4 feet long. I'm going to make the new one about 6.5 feet long. And I decided, and the problem with this is, this dimension is actually 1 9/16. It's typical wrought iron sizing was like a 1/16 of an inch under their nominal size. 1 9/16. I have not been able to find a supplier around here for it, so I decided to start from scratch with a piece of 1 15/16 shafting that I had, and I've got it set up in the lathe, and I'm going to turn it down to 1 9/16, and then turn the ends to 1 7/16 for the bearings. The bearings are 1 7/16, and I'm going to cut some keyways in the tight pulley of the tight loose pair, and I'm going to cut some keyways at this end for the forward drive and the reverse drive on the planer. Once I know exactly where the pulleys are going to have to be, I'll take it back down and cut the keys in it, so I won't have to monkey around with any of this slipping pulleys on the shaft with set screws. Finished cut on the bearing journal. I'm going to put a radius on the shoulder. So the tool bit that I have happens to be a carbide. So I'm going to use this tool holder that I usually use in the shaper that has no rake built into it. Okay, I hit the numbers right on the nose on this one. This one I got about 4,000 undersize, but it's not tapered. I got it polished up, and I can adjust the bearing. That's no problem. So I'm going to part this off partly, not completely, because I don't want this thing to fall down. I'll finish it with a hacksaw. Okay, there's the end. Came out pretty good except for this little spot right here where I got into it with a radius tool because I wasn't paying attention. So that's one end. This is a pretty straightforward job. I'm just plunging this cutter down in there to make a 5/16 keyway. Changed my mind. I'm putting the key up on the close end of the shaft because I want the tight pulley to engage the shaft when I pull the lever out. disengage when I shove the lever in. Basically the same as I have set up on the lathe. I let it run into this shoulder a little bit to make the keyway come out further, but it's not really critical. Here's the finish cut to the right depth. There's the finished slot, cut on the 1885 Brown & Sharp. This is the idler pulley on the tight-loose setup on the drive end of the countershaft for the planer. And the brass bushing in here that it spun free on the shaft was made for the smaller diameter on the countershaft, and my new countershaft is going to be a bigger diameter. So I'm boring this out slightly to fit that, and that'll make it straight and round and true. pulley has been repaired and overhauled a lot of times. See this sleeve that was driven over the snout, probably cracked underneath that. After 3 passes, got 573, which is just about what I was looking for. This is one of the bearing halves for the countershaft, line shaft, and it got dropped when we were taking it down and broke in 3 parts. It's very thin wall cast iron, and I'm going to braze it up. This is one of the hangers for the countershaft for the planer. This is sort of universally adjustable. It's got a jack screw from all 4 sides. This is the cap that was broken, and I re-poured it. It's a very difficult thing to pour because it has these extra cuts in here and on the ends. But the cuts here are for rings. Here's one of them here. They fit down in there and run around over the top of the shaft and distribute oil up over the top of it from the well. Down in here, and then this is the bottom half of the bearing, which carries 99% of the load, and it's sitting on a kind of a ball thing, so it can flop around in there. And then this part goes on top. Well, there's also a wick in there to pick oil up from the bottom. That's the top that fits on it. I can't say as I like this style of hanger. It's later model than the ones I'm using in the rest of the shop, and that's all I've got for the time being. But it's pretty loosey-goosey here, and you can't tell how much oil is in here till it starts running out the ends. I like my older style hangers much better. It's a much solider setup, although it's completely aligning. And it's true, you got to keep oiling them every day, but I use a lot better kind of oil than they had in the old days. And that little tray on the bottom collects it if it drips out the ends, and it's very solidly mounted, and I like the adjustment on it better. Filling up my feed water tanks. They were about empty. The countershaft for the planer is done, except for cutting the keyways, which I will do after I put it up and get the pulleys spaced out and I know exactly where the keyways should be in the shaft. But the two diameters are turned down on each end, and this is the loose pulley with the brass bushing in it. And this is the tight pulley, which will be keyed and set screwed onto the shaft. And the belt will shift over from one to the other to start and stop the machine. The big pulley here is the reverse on the table travel. The smaller pulley is actually the drive in the drive direction, in the cutting direction. And you can see this one's, the reverse is much bigger, so the table comes back faster than the cutting speed. The bearings are finished, and I've got collars made up to go inside of both bearings to keep the end travel from moving around. So these are about ready to put up. Here's another job I want to get out today. Customer's motorcycle wheel for the swing arm that I did. This is a case of moving the sprocket about 700 thousandths closer to the wheel. So he wants to machine 700 off of here and off this, and probably some off the sprocket carrier in order to get the sprocket to position in closer to the tire. Putting it on an older bike. I figured that the quickest and simplest way to grab this was by the brake disc, which is kind of precarious, but I've got a center on this side in the bearing too, so it's very rigid setup. Got the indicator on here, and you can see that it's mostly out of round by about maybe 5 thousandths, 6 thousandths. So I've got the different split on it, and it's ready to go. This is kind of tight because it's an 18-inch wheel, and the capacity of my lathe is 18 inches. But I can just get in there if you get everything kind of tweaked around just right. Too late to change your mind now. We're actually eliminating the cushion hub here. This is the sprocket hub for the motorcycle wheel. And I got to take about 700 off of that too. After about a half a day of screwing around with this, I think I finally got it straightened out. I cut the divider out of here, machined this down, machined these down, reduced the OD here, took 3/4 of an inch off of this, opened this up slightly so that it will drop right down in there, and the bearings come right together. This is a slightly bigger OD because there was a spacer that went in there with a thin wall flange on it. So whether he wants to weld this together or make some really dense cushions out of something, it's up to him. That's the way he wanted it. So that's that. This is a tractor pressure plate for a clutch, and customer wanted it resurfaced, so I took it apart. It's kind of unusual in that it has a big old Belleville washer for a spring. It's very easy to get apart, so we'll chuck this up, take off just enough to clean it up. It's a number 64 Starrett indicator, indicating in this direction. Got it within a couple. I've got a carbide tool in here because I'm expecting some hard spots. last job of the day. 20 to 5. Time to start cleaning up the machine and head home. Well, the countershaft is up, leveled, adjusted, lined up, and I'm making some belts for it. My good friend Mike Waller came by a couple days ago and happened to be here, and we just hoisted it up. I didn't get any video of it. This tight loose setup on the other end will be driven off the long line shaft, which will come through the wall up here, about 17 inches above the ceiling, into the other part of the shop. And it'll have a shift fork on the top run of that pulley. That'll have a rod that'll come through here. And I've been thinking I'm going to put a bell crank on it so that the rod will move horizontally, the control rod for the clutch, and it'll work this way like the lathe. This way for off, this way for on. So, next video, we'll be doing, putting the belts up on this, and I've got to do a little brazing up on the belt guides that shift it, because they've got some grooves worn in them pretty good. And then we will commence to hang the long shaft. Thanks a lot for watching. I appreciate your comments, and we'll see you next time.